let's go through this warm-up. So, first and foremost with quadratics, okay, we have seen quadratics a lot of the time. All right, you are familiar with quadratics from Algebra 1. So, for 5, what is our a value? Eleanor. Good. What is our h? Campbell. -1. Good. It's the opposite of what you see. What is our k value? Yeah, Noel. -2. So therefore, what's our vertex? Yeah, Eliza. -1, -2. Now, without graphing anything, what transformations are happening? What is 1? Yeah, Catherine. Left 1. Okay, what's another transformation? Yeah, Ryder. Down 2. Okay, so this comes from our parent function. People have asked, how do we know what the parent function is? You look at the exponent. If it's squared, then it's a quadratic. If it's cubed, if it's a cubic. If it's the square root's your parent function. If it's the 2 lines, that's absolute value. Okay, so that's how you could tell what your parent function is. And in blue, here's my parent function. Okay, and if you're unsure of how to come up with the points, okay, there's a pattern where the a value is 1. Okay, you always start with the vertex. The first perfect square is 1. So up 1 to the right and then up 1 to the left. Then back to the vertex. If we go up 4, over how many? 2, left, left and right. After 4, where would we go? Up how many? 9 and over 3 either side. So that is one trick to remember. The other trick is if you want to use the table of values, you put your vertex in the middle. -1, -2 is here. Then I would choose values 2 below and 2 above. All I would have to find is -3 and -2, because then I'll know 0 and 1, because it's symmetrical on either side. So if you use the table of values, vertex in the middle, and you could do 0 and 1, you will also know -3 and -2. Okay? So since I know the pattern, since a value is 1, I'm starting at the vertex, up 1 to the right, up 1 to the left, up 4, 2, okay? That's our new function. All right. Now for number 6, what is my a value? Okay, 1/2. What is my h? Yeah. 3. What is my k? Yep, Charlie. -5. Therefore, what's my vertex? Eleanor? 3, -5.
I have a question.
Mm-hmm.
Why is a 1/2?
It's always the number in front, right here. That's your a value. It comes from, I'll put it over here, y equals a x minus h squared plus k. That's where it's coming from. Okay. So what types of transformations are happening here? Grant, what's 1? Okay, right 3. Down 5. Is there another? Yeah, Eleanor. Good. Vertical compression by 1/2. Okay. So if we were to do our table of values, you could do the same thing. X, Y, with our vertex in the middle. Or I could show you by points. Okay. Because when you are doing vertical compression and down 5, which values do those change? X or Y? Vertical compression and down 5 affect what values? X or Y? Yep. The Y values. Okay? So if I go from, and again, if you are set plugging in X values to above and to below, then do it. Okay? This is showing you how it will change from the parent function. Okay? Because I might give you a point and say, transform it by this. Okay? And you have to know how to do that. Okay? So what that looks like is, I'm going to first take care of, X values can be done at any time since it's only changing once. So if these are my original X and Y, if I'm moving to the right 3, what operation is happening? How do I go from -2 to my next point? What do I have to do? Yeah. Add 3. Add 3 to X. So what's -2 plus 3? 1. -1 plus 3. 0 plus 3. 4 and 5. So that takes care of our right shift. Okay? Now, since I have 1/2, okay, I have to do this first. I have to multiply my original Y's by 1/2. So what's 4 times 1/2? 1 times 1/2. 0. And don't I have the same values on this side as well? Yes. Okay, so I multiplied my original Y's by 1/2. The last thing you have to do is do what to Y's? What's the last thing? Yep. Nope, not inverse. Not inverse them. So I carried those over. I took care of the multiplying by 1/2. Yep. Then I have to subtract 5. What's 2 minus 5? Okay. What's 1/2 minus 5? Then we have this, and then we have the other 2 points again. So you could have simply got these values. However, if you use the table of values, -2 to 2, you will only see one part of the graph. You won't see the whole entire thing. How many of you only saw 1/2 if you plugged in values? A few of you, okay. Which again, because they're symmetrical, you might be able to find the rest, right? But not all the time. So these would be my points of my new graph. Because that takes care of the vertical compression and moving down 5 all at once. Okay. Okay. That creates your graph. Okay. So we've dealt with a lot of quadratics so far. When you are graphing these, okay, do you always have to graph the parent function? No. But if you want to, do it, okay, to help with the transformations. However, when you're graphing quadratics, and on your pink sheet you could put this, quadratics, 5 points should be graphed, if possible. 5 points, your vertex and 4 others. 5 points should be graphed. Okay, so quadratics, 5 points should be graphed, your vertex and 4 others, to make a complete graph. Okay. We are going to get into the other functions on that pink sheet, so make sure you have it available. Okay? The next function is a cubic function. This as well, 5 points if possible. You could do 3 to 5. Okay? 5 points if possible, but you could do 3. Yes. Come up and get it. Okay? So, cubic functions, 3 to 5. 3 to 5. Okay? Basically, to start off, -1, 0, and 1, show your inflection point. Okay? Show this inflection point. So, if you notice, A, H, and K are the same, but HK is your inflection point, where it switches and makes the turn. Okay? Some of you saw this on, or all of you saw it on test, quiz, homework, whatever it was, thought that was constant, and it's not. Okay? It's an inflection point. All right? Meaning it's just making a turn. All right? So with the cubic function, and I'm going to do the parent function first, which you guys have in front of you. Okay, I'm going to graph the parent function first, just so we could see how this changes. Okay, so this is the same thing as well. A, H, and K. So for number 1, what is my A value? Jackson. 1. What is my H value? Nick. What is my H value? 1. Good. Zoe, what's my K value? What is it? 4. Good. So therefore, my point in inflection is HK. What would it be, Pearson? 1, 4. Okay. So based on my point of inflection for the parent function, 0, 0. If I needed to go to 1, 4, what transformations occurred? Victoria, what's 1? Careful. The right one. 0, 0. Okay. What other transformation happened, David? Up 4. Okay. So the transformations are still the same. X minus H, you're moving to the right. Plus K, you're going up. So all these points as well follow suit. Okay. And if you wanted to know new other values, say if I plugged in -1. What's -1 minus 1? -2. So if I do x equals -1, what's -2 cubed? -8 plus 4. -4. So I also have a point, -1, and I was off here. Right here. Okay? All right. So, again, doesn't matter what graph you have, the shape might change in terms of the parent function, but the transformations are still the same. So let's look at, we're going to do 2 together, and then we'll go from there. Okay, for 2, what's my A value? Kaden. 1, good. James, what's my H? Okay. Jaden, what's my K? -2. See. Christian, what's my point of inflection then? For -2. Awesome. Okay. So with that being said, what's one transformation happening? Eliza. Right 4, good. You okay? And then KR, what other transformation? Down 2. Okay. So or -2. And this is a prime example where you could only graph the 3, but showing the trend. Okay. All right. Try B on your own. Try B. In green, I just graphed the parent function. Okay. I just graphed the parent function. What is my A value? Noella. -3. Good. Riley, what's my H? 0. Good. Ryder, what's my K? 0. Yeah. What is my point of inflection? Izzy. 0, 0. Good. So that has stayed the same. Okay. Our point of inflection has stayed the same. What is one transformation happening? Kip. Yes. You will call it a vertical stretch. Excellent. Because 3 is greater than 1, right? Vertical stretch by 3. What else is happening? Yeah, a reflection. The negative in front means a reflection. So what we would do here, especially these points in the point of inflection, 0, 0, if I multiply 1 by -3, what do I get? Yep. -3. So x value would stay the same. However, that would be my new point. How about -1 by -3? Yep, Jaden. 3. Bless you. So again, we have a stretch and it's reflection, meaning it's going in the opposite direction. Questions? How many of you had this right? Okay, good. Excellent. Right. Question?
I was wondering, what exactly is the point of finding A?
Because it tells you if it's a stretch or compression or reflection. You need to multiply your y values by that. Okay? All right. Try C on your own. Okay. So for C, KM, what is my A value? 2. Good. Campbell, what's my H? Good. K, Catherine. 1. Good. Point of inflection, Tommy. Good. -1 and 1. Okay. What types of transformations are happening? Nick, give me one. Vertical stretch by 2. Good. Grant, give me another. Left one. And Zoe, what's another? Good. Okay. So we have this. Okay. Now, to find your additional points, okay, you could take my next x value. Say 0. 0 plus 1 is what? 1 cubed. 1 times 2 plus 1. 0, 3. The other value. How about if I plugged in -2? What's -2 plus 1? -1 cubed times 2 plus 1. Okay, and you could obviously do more points if there was enough room on the graph. Okay, but this is what it looks like. And again, it's continuous. Okay, your cubic functions are continuous, so it goes, any x value you put in, you will get a y value. Okay, it doesn't stop. Okay, the next graph is absolute value functions. Definitely 5 points. And again, if the graph doesn't allow, do as many as you can. Okay, so absolute value functions are very similar to quadratics. Okay, they have a vertex, which we use HK. Okay, HK is our vertex. The same letters apply, A, H, and K. However, with absolute value, the A value, you could use slope for. Okay, the A value, you could use slope for. Okay, absolute value is by far one of the easiest to remember and do. Okay, so we're going to jump right into this. What is my vertex? Okay, 3, 1. Okay, so if my vertex is 3, 1, what types of transformations happened? What is one transformation? Jaden. Right 3. Tommy, what's another? Up 1. Good. What is my A value here? Okay, 1. So therefore my slope is from the vertex up 1 to the right. Whatever I do to the right, I also have to do to the left. Then I continue from my points, and I continue on. Okay, it's the same. Okay, your A value is 1. Okay. Now for B, what is my vertex? Yep, Jack.
-1, -3.
Be careful. -3 is correct.
-2, right?
Do you see anything adding or subtracting to x? Like inside those brackets?
Would it be 0?
Yep. Okay. Be 0, -3. 0, -3. So what transformation just then happened? What's one transformation? Kate? Down 3. Now, what is my A value? Yeah, Riley. Okay, my A value is -2. So what is happening to this graph? What's one transformation happening? Tommy? Reflection, because it's negative. And what else? Yeah, Eleanor. Vertical stretch. Okay. So if my A value is -2, my slope must be what? -2. So from our new vertex, I'm going down 2 to the right, down 2 to the left. And that's all I could see from this graph. But it continues.
So, if the slope is negative, that means that it goes down.
Yep. And this is off on this side. Yep, it means it opens down. Okay? And the last function is our square root. Okay? This, primarily, you probably can only get the 3 points. 3 points graphed for square root functions. Okay? And it's only the positive values, 0, 1, and 4. You could do 0, 1, 4, 9, 16, so on and so forth. Okay? The HK is our starting point. HK is our starting point. So if you notice, HK means something in all of these functions. Either vertex, starting point, inflection point. Okay? HK is our starting point. So, for A, what is my starting point? Jax? 2, 1. Okay? So based off of that new starting point, what transformations are happening?
Is like when it goes out, like
Not for, if the A was like 1/2.
so it only
If
it doesn't only count if both sides go out.
if there's an A value of 1/2, that means it's a compression. What types of transformations? Eleanor. Right 2. What's another? Yeah, Caleb. Up 1. So many questions have come up. How do I know what values to use? Well, you could pick values, x values. Obviously, it has to be larger than this because we can't do -1 because we'll get a negative inside. So choose the one right next door. 3 minus 2 is what? Is 1. What's the square root of 1? 1 plus 1. 2. So I have a new point, 3, 2. But can I use the next x value, which is 4? What's 4 minus 2? Square root of 2. I get a decimal, right? So what would be another x value you could use if you needed to? Yeah, Jaden. 6. Because 6 minus 2, square root of 4, plus 1, 3. 6. Okay. All right. All right. Try B and C. All right. For B, what is my starting point? Yeah, so, yep. What's my starting point? Jaden. 0, -3. What types of transformations are happening? Noelle, give me one. Reflection, good. Jax, give me another.
Do you think that it would be a stretch?
No. The negative in front only means reflection. Okay, the negative in front means reflection. Then we're moving down 3. Okay, so we have 0, -3. Okay, what would be my y value for 1? Kate? -4. And then if I was to choose my x value of 4, what would I get? Yep. -5. Good. Good. Okay. Yes.
How is the A a reflection?
A is in a reflection because it's a negative in front.
Oh, I thought that it was a reflection if it was reflected off y-axis, like.
X-axis.
Oh.
It's always the x. Okay, so the negative means a reflection only. Okay, negative reflection if there's an A value. Now, yep. Correct. So C, what is my starting point? Yeah. -1, 0. What types of transformations are happening? Yeah. Vertical stretch by 2. This is a vertical stretch because the 2 is our A value. What other direction am I moving in? Yeah, Kip. Left 1. Okay, so my starting point. Okay. Now if I was to plug in 0, that's right next to it. 0 plus 1. 1. The square root of 1. 1 times 2 is here. Then if I was to plug in 3, and I chose 3 because 3 plus 1 gives me 4, square root of 4 times 2. Okay, and that's our function. How many of you did have B and C correct? Not a lot of hands. Why? Go through these. Okay. Describe the transformations to the graph. F of x equals -1/2 absolute value of x plus 3 minus 2. Pearson, give me 1. Yep. Reflection, good, because of the negative. Excellent. Victoria, give me another. Good. Left 3 because of the x plus 3. David, give me another. Down 2. James, give me another. Good. Vertical compression. Oops. Okay. So, this function, the negative, meant a reflection. Okay. Left 3. X plus 3, it's the opposite of what you see, so it's left. Down 2. And the compression, because it's a 1/2. Okay. It's a fraction. How many of you did get that right for number 1? Okay, good. For A, we have our quadratic. Caden, what's our vertex? 0, -3. So what transformation happened, Christian? Down by 3. So we start here. The A value is 1. Okay, 1, 2, 3, 4, 2. And here is our function. Yes?
I think it has a vertical stretch by 1.
The vertical stretch has to be greater than 1 or in between compressions in between 0 and 1. So 1 does it, it's just a normal shape. Doesn't change it. Okay? Eleanor, what's my vertex? For B. Careful. 1, 4 is my vertex. Okay. So 1, 4 is my vertex. What transformation happened? Give me 1, Charlie. For B. Be careful. Okay. Up 4, Eliza, what else happened? Right 1. Okay. And this is absolute value, so we could use our slope, which is what? 1. Okay. C. What is my starting point? KR. -4, 0. Good. Okay. What's one transformation? Noella. Good. And Riley, what's another? Left 4. Good. Okay, so this came up before. You have your starting point, which is opposite what you see. Okay, we have the negative, which is reflection. So I'm just going to substitute in -3, which is the next x value. Okay, -3 plus 4 is 1. Square root of 1 is 1 times -1. Gives you -1. Okay, and they can do 4. I can plug in 0. 0 plus 4 is 4. The square root of 4 is 2 times -1, -2. And that's our function. Okay. Questions on those 3? Okay. For 3A, for what values of A does a reflection across the x-axis take place? Ryder. Good. When A is less than 0. meaning it's negative. Okay, reflection takes place when A is less than 0. And for B, what are the coordinates of its vertex using A, H, and K? What are the coordinates? What do we got? Who has that one? Eleanor? Okay, HK, and what are the vertex? Good. Okay. The vertex is HK always. Okay. The vertex here is 3/4 and 7/2. Okay. What else do we use HK for? For any other graph? We have the vertex is number 1. What else? Catherine? Starting point. What's another? Point of inflection. Awesome. Okay. So we went through all of our transformations, okay, with all of our functions today. Okay. You guys are going to work on some practice. Whatever you don't finish is for homework. Okay. If you could